Well, let's get this in. There we go. Should be good. Hello again, everyone. I want to talk about a couple things that are coming up. I want to look at these three equations for an example. You'll see them in more detail on slide 25, but I'd like to look at domain and range. And also in a couple slides, you'll see what this f at x is. Okay, so let's start there. Okay, why would I write something as f at x equals 1/2 x minus 3 when generally we're familiar with this? Y equals 1/2 x minus 3. Okay, so I want you to realize that whether we use f at x or y, that y and f at x are equal to each other. All it is a change in terminology, and you'll see this as you go on and take more math courses. Instead of using the y, they'll use the f at x notation, and I'll put that in purple. Okay, it doesn't change anything when you graph it. Okay, you're graphing here. This is still x. Now instead of y, this is f at x. But remember, f at x is equal to y, right? This is still the dependent variable and the independent variable, right? And it's when you get into functions, it's saying the function where the independent variable is x is equal to 1/2 x minus 3. And you might be like, okay, great. Why don't you just leave a y there? What's the difference? So for us mathematicians, we look at it this way. If I write f at x equals 1/2 x minus 3, and I'd like to substitute for x, I don't have to say, I would like you to substitute 4 in for x. Instead of saying all that, I can write f at 4, and what that means is I would like you to substitute 4 in for x, but all I have to do is write f at 4, and you would know that means I have to put 4 in for the x, and then f at 4 would equal 2 minus 3, which would be -1. Okay, so it's a notation that allows for substitution without having to write a lot of words. Okay, and you're like, well, okay, whatever. The difference is this. If I did this, and I wanted to substitute in 4 for x, I would have to write down, now, substitute x equals 4, okay? And us mathematicians, we don't like too many words, right? So instead of doing that, we're saying, well, I want to be able to just do this and have it mean the same thing, okay? So you'll see as you go along, this f at x becomes more common, but really just think it's the same thing as y. It's not a big change. It's not really any change at all. It allows us to talk about math a little more quickly. That's it. Okay? All right. Enough about that. Let's look at domain and range here for this one. If you're doing something like this, you have a linear function. This is going to graph to be a straight line. I know that because the highest exponent is 1, and everything that has a highest exponent of 1 graphs to be a straight line. Okay? So anytime I'm graphing a straight line, okay, I know the domain and the range go from -infinity to +infinity. So take a second, look at the three of them. This is almost like a little pause, and see what you see. I'll just give you a second or two. I'm not expecting you to do it, just to have a little look at all three of them. Okay. All right. So in one of these, where the highest exponent is 1, we're going to go from -infinity to +infinity. And as we saw earlier, we would use parentheses. Same thing here. We're going to go from -infinity to +infinity. We'd use parentheses. Okay. This one here is a cubic. Now the shape of a cubic happens to be something like this. It comes from here, it comes up, it's going to have a couple of turns, and it's going to keep going. Okay? So now, even though it had some terms, all values of x will work. There's no value of x that I could substitute that would make this equation not work. I could put in any number for x I want, and I could do the calculations and get a value for f at x, right? Which means the domain is the same. So not very exciting. Oops. Negative infinity to infinity. The range is also not very exciting. Just based on the graph, it looks like y heads to negative infinity or positive infinity. Not very exciting. Okay. It would be, and I'll get a different color here, it would be a little more interesting if this was a 4, because if it was a 4, we actually have a graph that looks like this. It's going to have some terms in it, but it's going to both head to positive infinity, which means there actually is a smallest y value. We're not going to get into that yet. So it'd be a little more exciting if it was a 4, but it's not. It's a 3. Okay. It's a 3. We'll give it back to a 3. Okay. Now the bottom one here is a little different. You could say, well, does every value of x work? It's not true, right? It's not true. Not every value of x works, because if I just focus on the bottom, 2x plus 1, if 2x plus 1 were to equal 0, we would have a problem, because we'd be dividing by 0, and we can't do that. So we say, okay, 2x, so 2x minus 1 cannot equal 0, which means 2x cannot equal negative 1, which means x cannot equal negative 1 over 2. Okay? So we don't have this negative infinity to positive infinity. Okay? Take a second, just kind of see what you think about that one. Okay. So now really what we're looking at is we're looking at a bit of an issue here. Okay? We have something like this. We have a domain, oh, I'll use purple, sorry. We have a domain that goes from negative infinity to negative 1/2. Okay? But it doesn't include negative 1/2. It doesn't include it. And then it's also, we use this fancy, continuation of negative 1/2 to positive infinity. And when you look at it, go back to your interval stuff and where we use the brackets and where we use the parentheses, and you'll see how that works there. Okay. There's also a range that won't work. There's a value that won't work for y potentially, right? Because if I can't put in negative 1/2, isn't there something that won't work there potentially, right? And that's something that we'd have to figure out and we'd have to solve. So we're not going to worry about that right now, okay? But I do want you to understand that it's not always negative infinity to positive infinity for a domain. As we get these different rational functions, there are some numbers that do not work, okay? You may have learned it and see it like this. The domain is, we got a brace, x is not equal to negative 1/2, but x is an element of real numbers. You may have learned it like that, okay? And that's okay too. It's just a little different. It's saying x cannot be negative 1/2, but x is an element of real numbers, so it can be any other number except negative 1/2. And that's acceptable as well. It's a different way of looking at it, okay? So that's where we're at. A little bit of domain, a little bit of range, a little bit of dealing with f at x instead of y.